math for no reason. In this edition, we are looking at the Fibonacci sequence. The Fibonacci sequence starts with the terms 1 and 1, and subsequently un is the sum of un minus 1 and un minus 2 for all n greater than or equal to 3. We intend to show that un plus 1 into un minus 1 minus un square is equal to minus 1 to the power n. Now, if we write down the first few terms, so you have 1, 2, 3, 5, 8, 13 and so on. When n is equal to 2, we can directly verify LHS is u3 u1 minus u2 square, putting n is equal to 2 here. u3 into u1 is 2, u2 is 1, so you get 2 minus 1, which is 1, and you can write 1 as minus 1 whole square. Again, for n is equal to 3, through direct computation, we see that the equation holds. So let us see if we can get a general form of this. Let Pn be equal to un plus 1 into un minus 1 minus un square. We will show that Pn plus 1 plus Pn is equal to 0. Or rather, Pn plus 1 is minus Pn. So let's try to do this. Now, we write un plus 2 as un plus 1 plus un into un minus u square n plus 1 plus un plus 1, and we write un minus 1 as un plus 1 minus un, and we subtract un. Now this gives us, so un into un plus 1 cancels, un square cancels, u square n plus 1 also cancels. So we get 0. So we have proved that Pn plus 1 plus Pn is equal to 0. So we know that P3 is minus 1. So P4 plus P3 is equal to 0. So P4 is minus or minus 1, so it is 1, which is minus 1 to the power 4. Similarly, we can show for every n, Pn is going to be minus 1 to the power n. A simple induction argument will do this for us. So assume Pn is equal to minus 1 to the power n. Then Pn plus 1 is minus of minus 1 to the power n, which is minus 1 into minus 1 to the power n, which is minus 1 to the power n plus 1. Thus, by induction, we can claim that Pn, which is un plus 1 into un minus 1 minus un square, is equal to minus 1 to the power n for every n greater than or equal to 3. So thus we can claim by induction that Pn is equal to minus 1 to the power n. That proves our claim. Thank you.